Good morning, Ms. McManus.
Good morning, Mr. Lumsden.
So we just did an experiment where we reacted some copper solution with some solid zinc, and the zinc was able to displace the copper from solution, and it was exothermic. So we produced some heat as well.
Okay, and from the data, we can calculate the delta T, the temperature change, and find the energy change of the reaction.
So let's look at the data. Here we are, and we've got two columns of data, X and Y, and we've got a decent looking graph here, but what's our first problem?
So we first need to put some axes labels. So if you double click on the X at the top of the column, you can change that to time. And also important, we need to add seconds for the units.
And this one is the temperature. And we want degrees Celsius. We have a little degree guy here, and C. So that automatically shows up on our graph, so that's helpful. Next step, we need to figure out what it was, the temperature change. So what was the temperature at the beginning of the reaction?
So we can highlight these points at the beginning where we've recorded the initial temperature, and we can extrapolate the line clicking the linear fit button.
I can do linear fit over here or somewhere else. And where should I select for the other ones? Well, I guess these guys here.
So we're clicking for the cooling trend.
So I didn't have a perfect insulated beaker. Okay, so I've got two trend lines. That's nice. And we would like to know the difference. And because we added the zinc at 180 seconds, we want to find out the value at 180 seconds. So we're going to click on examine. And if I drag this to, oh, look, there it is there. But that doesn't tell me the whole story. It tells me the data point at 180 seconds. It doesn't tell me the intersection of the two lines. So I need to turn on this other function here, interpolate. And now that changes the data we get out to, I think about there somewhere. Let's call it that. So our initial temperature was 20.172 and our final temperature was 58.610. And that's what we need to calculate our delta T. That's it.
Ta-da!